Have you ever wondered how Adidas turns plastic waste into high-tech sneakers? Every year, more than 400 million tons of plastic are thrown away around the world, and only a tiny portion gets recycled. But inside a factory in Germany, tons of that waste gain a new purpose. They become shoes engineered with precision and built for performance. It is like watching an environmental crisis turn into industrial-scale innovation. Today, we are stepping inside one of Adidas's largest facilities to see how millions of sustainable sneakers are made, from raw plastic waste all the way to the finished product on store shelves. If you love learning how things are made and how the world works behind the scenes, make sure to subscribe and get ready. You will see what modern technology can create from what most people call trash. The production of Adidas sneakers made from recycled materials begins with one clear mission: transform plastic waste into high-performance industrial components. Inside the German facilities, every stage is engineered with precision. The goal is to take discarded material and give it real value. This is part of a global sustainability strategy that applies strict efficiency and quality control from the arrival of raw materials to the final finishing steps. The process starts with tons of plastic bottles and discarded fishing nets collected from different countries. These materials arrive compacted into large bales that go through inspection and source verification. A rigorous sorting phase removes anything that could compromise the final quality. Nothing enters the production system without analysis. This level of attention ensures the purity of the polymer that will later be reused in the manufacturing process. After sorting, the material is prepared for its first industrial step: conversion into plastic flakes. The purpose here is to reduce size and create consistency for the next stages. Everything is processed on an industrial scale with temperature, pressure, and speed carefully controlled. The result is a clean and uniform plastic ready to be transformed into recycled polyester, the primary material used in Adidas shoe fabrics. This method represents an advance in high-tech footwear manufacturing. It combines traceability, chemical control, and highly standardized procedures to maintain consistent quality in massive production volumes. The outcome is a reliable foundation for high-performance sneakers made with the same precision as traditional models, but with a far smaller environmental footprint. From this point on, the material begins its industrial journey, evolving from waste into a valuable resource for modern sports engineering. The manufacturing journey begins long before the plastic reaches factories in Germany. A worldwide supply chain collects post-consumer bottles and discarded fishing nets from more than 30 countries. These materials arrive in labeled shipping containers with composition reports. Each batch is weighed, sampled, and tested in a lab to meet the standards required for athletic footwear production. Most of the recycled plastic comes from coastal areas and high-consumption urban regions. At partner facilities, the waste is sorted by density and polymer type. PET bottles are the primary ingredient used in Adidas sneakers. PET offers high strength, low weight, and can be processed several times without significant quality loss. This is what makes it ideal for producing durable and flexible yarns used in the upper of each shoe. The materials arrive in Germany compressed into blocks of about 500 kilograms each. After unloading, they go through visual inspection and are moved into pre-wash tanks. This step removes sand, salt, and tiny metal particles. The plastic is then shredded, filtered, and dried in thermal chambers until moisture levels drop below 0.05%. That precision prevents defects during melting and yarn extrusion. Adidas maintains this strict control to ensure global uniformity. Each shipment is digitally tracked from arrival to final assembly. This system supports a sustainable production chain where technical accuracy meets environmental commitment. From here, the material is ready for the core phase, turning plastic into high-performance synthetic yarn. Inside the Adidas facility in Germany, the first physical transformation begins. The compacted blocks are broken down into uniform plastic flakes. Shredding machines operate in stages, starting with primary crushing to reduce volume, followed by high-speed cutting blades that break material into tiny pieces just a few millimeters wide. After shredding, the flakes are sent to industrial washing units. Heated tanks with neutral cleaning solutions remove oils, dyes, and organic residue while preserving the polymer's integrity. Next, the flakes enter centrifuges that eliminate moisture and leave purity levels above 99%. This is essential to produce high-quality recycled polyester. Then comes density separation. Decanting tanks and optical sensors classify the flakes so only pure PET moves forward. Anything unsuitable is diverted for other industrial uses. This prevents performance variations and keeps every batch consistent in strength and elasticity. The output is clean, uniform, and chemically stable plastic, ready for textile transformation. Each ton processed here represents about 60,000 recycled bottles. Lot-by-lot tracking ensures full traceability. With this stage complete, the material is ready for one of the most critical steps, melting and spinning it into continuous recycled polyester yarn. Approved plastic flakes go to fusion and extrusion. They are heated in controlled tanks at temperatures that can exceed 280 degrees Celsius, melting the PT without altering its chemistry. Once molten, the liquid polymer is filtered and pushed through precision metal micronozzles, forming fine continuous filaments. Those filaments are cooled in controlled air chambers to prevent deformation. Then they are mechanically stretched to boost strength and flexibility. This process is similar to industrial synthetic fiber production, but calibrated for Adidas standards. The result is a recycled polyester yarn with performance comparable to new petroleum-based fibers, but with a far smaller environmental impact. After stretching, the yarns are bundled and wound into standardized spools, each marked for traceability. Quality tests check tensile strength, diameter, and color uniformity. Samples undergo heat, humidity, and twist simulations to ensure long-term durability. Only then does the yarn move to the textile sector. This recycled polyester forms the base of Adidas's high-tech shoe uppers. It delivers lightweight durability and flexibility for athletic performance. It also reduces reliance on fossil fuel materials, closing the loop between waste and new product. Next, the yarn enters digital weaving machines to become precision-engineered fabric ready for shaping into footwear. With the recycled polyester yarn ready, it is time to turn it into technical fabric. Inside Adidas's German facility, spools are placed in advanced computer-controlled looms. Hundreds of threads move simultaneously under precise tension settings, spacing, and programmed weaving patterns. The goal: a lightweight yet strong fabric that handles repeated flexing without losing structure. The process is continuous and extremely precise. Speed and temperature settings adapt to each shoe model. Even a tiny misalignment could affect how the upper fits the foot. High-accuracy sensors constantly monitor fiber tension and placement to maintain perfect uniformity and performance consistency. The result is a seamless, one-piece upper fabric. No seams means less waste, fewer weak points, and greater comfort. This technique optimizes production efficiency and reduces material waste compared to traditional methods. The digital system also allows different zones of density and texture in a single piece, shaping to the natural movement of the foot. Every meter of fabric passes through an optical inspection before cutting and assembly. The outcome is a recycled material upper engineered for durability, comfort, and performance. From here, the fabric moves to design and biomechanics refinement, where cushioning, structure, and comfort engineering come together to shape the final sneaker. Once the fabric is ready, it moves into the technical development area, where engineering and design come together to turn raw material into real performance. Every sneaker model goes through a three-dimensional digital modeling phase. This is where fit, shape, and weight distribution are simulated to predict how the shoe will respond to impact and movement. The goal is to deliver stability, lightness, and breathability without adding extra material. Engineers at the Adidas facility in Germany rely on biomechanical data collected in performance labs. These tests help identify the areas of the foot that experience the most pressure while running or walking. With that information, they adjust fabric density and midsole thickness to create the right balance between comfort and performance. Each prototype is refined until it meets the brand's standards for athletic technology. Along with structural fine-tuning, designers also evaluate ergonomic comfort. The upper needs to adapt to different foot shapes without causing pressure points. To achieve this, Adidas uses anatomical molds and built-in ventilation channels that improve airflow and flexibility. This design approach makes the shoes lightweight and durable, serving both athletes and everyday users. Every detail is tested before the shoe moves to full-scale production. Tests include impact absorption, compression, and elastic recovery. No component is approved without technical certification. This step completes the development of the upper and prepares the shoe to receive the cushioning base. That is where recycled foam is molded into the sole, which provides energy absorption and stability. Next comes the creation of the soles. This phase uses a blend of polyurethane and rubber recovered from industrial waste. The material is ground, filtered, and mixed in high-pressure tanks until it reaches the ideal density. The formula changes depending on the model. Running shoes need more impact absorption, while lifestyle sneakers prioritize stability. Temperature and viscosity control are key to forming a uniform recycled foam. The mixture is injected into specially designed metal molds. These molds operate at high temperature, usually between 180 and 200 degrees Celsius. As the material heats, it expands and fills every chamber, forming the pockets responsible for flexibility and cushioning. Cure time is precisely controlled to avoid bubbles and warping. After cooling, soles are removed, inspected, and sanded for a smooth and grippy finish. Each batch goes through density and compression checks. Random samples are cut and analyzed in a lab, where they are exposed to varying heat and humidity levels. Wear resistance is a main quality benchmark. Only soles that pass all tests move on to assembly. This ensures durability and performance that meet the company's athletic technology standards. Using recycled foam marks another milestone in Adidas' sustainable manufacturing process. It reduces industrial waste and allows millions of pairs to be produced without sacrificing performance. Each mold can be used hundreds of times, saving energy and resources. Once ready, the soles move to the assembly line, where they will be joined with the uppers. At this point, the sneaker begins to take its final form, evolving from separate parts into a functional product. With soles and uppers ready, assembly begins. This stage brings all components together with precise alignment. The upper is positioned over the internal structure and bonded to the midsole using water-based eco-friendly adhesive. Heat-controlled application ensures perfect bonding without damaging materials. Then the sole is placed and pressed with uniform pressure, creating a permanent structural bond. Cure time varies by model and material. After bonding, the shoe moves to high-precision stitching. These machines reinforce key stress areas, especially around the heel and arch. The goal is maximum strength without adding weight. When internal reinforcement is needed, recycled polymer supports are inserted to improve stability. This method is standardized across Adidas facilities in Germany, ensuring consistency from one product line to another. Next is quality control. Each pair is visually inspected and then measured by automated systems. Sensors check weight, symmetry, and stitch alignment. Any pair outside tolerance goes to correction or removal. Random samples undergo flex and traction tests that simulate real-world use, ensuring the shoe maintains its structure even after thousands of impacts. Once approved, the sneakers are cleaned, labeled, and packed in recyclable boxes produced within the same sustainable production system. Each batch receives a tracking code that links it back to the original plastic collection process. This traceability reinforces transparency and efficiency. After this step, the shoes go through their final performance trials before heading to stores worldwide. Before reaching the market, every sneaker faces rigorous testing for performance, durability, and stability. In advanced testing labs, machines simulate months of use in just a few days. Continuous flexing, pressure, and twisting movements test material resistance. The goal is simple: ensure the shoe maintains its mechanical properties without collapsing, tearing, or deforming. Thermal and humidity tests follow. Shoes are exposed to temperatures from -20 degrees Celsius to 60 degrees Celsius and placed in condensation chambers to evaluate recycled materials under extreme climates. This step is crucial for global consistency in sports footwear performance. Adidas uses the results to fine-tune foam formulas, adhesives, and fabrics before mass production begins. Biomechanical tests with volunteers and athletes add another level of validation. These tests measure joint impact, lateral stability, and traction on different surfaces. The data collected goes into a performance database used to develop future models. This method supports Adidas' commitment to technical accuracy and ergonomic comfort in athletic footwear. Only after passing all tests is a sneaker approved for sale. Each pair receives an internal certification guaranteeing compliance with brand standards. This thorough validation process builds consumer trust and ensures consistent quality. At the end of the cycle, the factory closes the loop with a sustainable recycling program that allows old shoes to be returned and reintroduced into production to create a new pair. In the final stage of Adidas sneaker production, the focus shifts to closing the loop. That means reusing materials and keeping waste to an absolute minimum. Inside the facilities in Germany, all leftover fabric, foam, and plastic are collected, shredded, and fed back into the system. This approach ensures that almost nothing is thrown away. The company maintains a reuse rate above 95%, supported by a material tracking system that monitors every batch from collection to final product. When a shoe reaches the end of its life, it can come back too. Dedicated return programs allow used sneakers to be disassembled and separated by material type. Reusable parts go back into melting and extrusion, while components that can't be recycled are redirected to controlled industrial processes as alternative fuel. This sustainable footwear model reduces carbon emissions and strengthens circular economy principles inside the brand. Beyond recycling, Adidas invests in green infrastructure. The facilities run on renewable energy and industrial water recovery systems. Temperature and ventilation are monitored by smart sensors to reduce energy use without affecting machine performance. The long-term goal is carbon neutrality across the entire high-tech footwear production chain, turning sustainability into a core piece of the manufacturing structure itself. This closed-loop concept is reshaping the future of the sports industry. The same material that once polluted oceans now serves as the foundation for durable, comfortable, and technologically advanced footwear. With every new pair produced, the system becomes more refined, proving that innovation and environmental responsibility can coexist inside the same manufacturing plant. The result is an intelligent, efficient production system capable of turning waste into real performance. From plastic collected in the ocean to sneakers ready on store shelves, this journey shows how engineering and sustainability can move side by side in modern manufacturing. Every step in Adidas production is designed to turn discarded material into high-performance footwear. What once was waste now becomes part of technology that moves athletes and consumers around the world. This sustainable footwear model represents a major shift in how the industry operates. It reduces waste, saves resources, and inspires other companies to rethink their processes. Instead of relying on limited raw materials, Adidas demonstrates that innovation also means producing without leaving a negative mark on the environment. It is efficiency applied to engineering at scale. The technology used in these factories does more than create a better product. It redefines what industrial responsibility looks like. Each pair is proof that comfort, performance, and environmental awareness can exist together in the same process. And as new techniques emerge, the goal becomes even clearer. Eliminate waste completely and operate a fully closed loop system inside the factory. Now tell me in the comments, did you ever imagine a sneaker could be made from recycled plastic? If you enjoyed seeing this industrial transformation up close, like the video, subscribe to the channel and keep exploring with me the behind-the-scenes technology that moves our world.